This lesson is based on the textbook Modern Welding, 11th edition. If an alternate edition is used of Modern Welding, you will have to look up the chapter that pertains to the material covered. Chapter 16, Brazing and Braze Welding. Objectives. Differentiate between brazing and braze welding. Select the proper filler metal and flux for brazing or braze welding a particular joint. List the things which must be done prior to brazing or braze welding to ensure a strong finished joint. List, in the proper order, the procedures for making an acceptable brazed joint. List, in the proper order, the procedures for making an acceptable braze welded joint. Describe the possible health hazards involved with brazing or braze welding. Brazing and braze welding. Brazing is a group of processes that produce coalescence of materials by heating them to the brazing temperature in the presence of a filler metal having a liquidous state above 840 degrees Fahrenheit and below the solidus of the base metal. Coalescence means the joining or uniting of materials. Brazing and braze welding. Braze welding is a joining process that uses a filler metal with a liquidus above 840 degrees Fahrenheit and below the solidus of the base metal. Brazing has been used for centuries. It is an important industrial process used to fabricate heating, air conditioning, and refrigeration equipment. Brazing and braze welding. Brazing is also used in jewelry making and is effective in joining similar and dissimilar metals. Brazing and braze welding usually imply the use of a non-ferrous alloy. Brass is an alloy consisting chiefly of copper and zinc. Bronze is an alloy consisting chiefly of copper and tin. Brazing and braze welding principles. Brazing is an adhesion process in which the metals being joined are heated but not melted. Adhesion is the molecular attraction exerted between surfaces. Brazed and braze welded joints are stronger than a soldered joint. Brazing is done on metals that fit together tightly. Brazing and braze welding principles. Molten filler metal enters the joint by capillary action. Before brazing, base metals must be cleaned prior to adding filler metal. Proper flux and filler metal must be used. Sometimes cleaning is required after brazing is complete. Safety. It is important to provide excellent ventilation when brazing or braze welding. Fumes from some heated fluxes and filler metals are toxic. They can affect the respiratory system, eyes, and skin. Joint designs for brazing and braze welding. Braze welding is a process in which a thick layer of filler metal is used. A convex or concave bead is created. The fit of the joint is not as critical as that required for brazing. The brazing process is similar to soldering because it uses a much thinner layer of filler metal than braze welding. Joint designs for brazing and braze welding. Brazing requires that the joint be well supported until it has cooled. The proper clearance between the parts in brazing a joint is critical. Brazing is often done on dissimilar metals that have different expansion rates. These expansion rates must be considered if parts are clamped or restrained. Joint designs for brazing and braze welding. This illustration shows typical braze welded joint designs for use on containers. Flush lap, flanged bottom, double lap, flat lock seam, flanged edge, and flanged bottom. Cleaning base metals prior to brazing or braze welding. Clean parts are required for brazing. Oil and grease must be removed from parts using a proper solvent, chemical cleaning. Next, a chemical pickling solution is used to remove any scale and rust. Mechanical cleaning and chemical cleaning are essential in preparing many base metals. Cleaning base metals prior to brazing or braze welding. Mechanical cleaning is done with a grinding wheel, media blasting, emery cloth, and/or wire brush. This illustration shows how a strong bond is formed between cast iron and the braze alloy after brazing. Safety. Be sure to follow all safety procedures when using chemicals for cleaning. Always follow safety procedures when using tools to clean. Be sure to have proper ventilation when brazing or braze welding. Brazing and braze welding fluxes. A flux is a material used to hinder or prevent the formation of oxides and other undesirable substances in molten metal and on solid surfaces. It will also dissolve or otherwise facilitate the removal of such substances. Flux also aids in the flow of the alloy filler metal on the hot base metal. Brazing and braze welding fluxes. Fluxes must be chemically pure. It is best to refer to the manufacturer's recommendations when selecting a flux to use on a specific metal. Fluxes can be purchased in powder, paste, or liquid form. Brazing and braze welding fluxes. Consider these factors when choosing a flux: the base metals to be joined, the filler metal used, the heat source, ease of flux removal, possible corrosive action on the metals, health hazards, and electrical conductivity. Applying brazing and braze welding flux. Flux material can be sprayed, brushed, or applied with a pressurized applicator. During brazing or braze welding, the brazing rod is usually coated with flux. Brazing rods can be purchased with the flux commercially applied to the entire rod surface. Applying brazing and braze welding flux. A method that eliminates the handling of a separate flux is to feed the flux into the fuel gas. Brazing filler metals are available in a powdered form. Applying brazing and braze welding flux. Powdered braze metals can be mixed with flux and injected into the welding flame. Another way to apply flux and filler metal is to form a paste. The paste is then added to the joint. Pastes used for brazing typically combine powdered filler metal and flux with a binder. Brazing filler metal alloys. For every brazable metal, there is at least one type of filler metal brazing rod made. Factors to consider when selecting a brazing rod include the brazing and service temperatures required, compatibility with base metals, and method of heating. Brazing filler metal alloys. Brazing and braze welding methods require an understanding of two critical temperatures. Melting temperature is the temperature at which an alloy begins to melt, solidus. Flow temperature is the temperature at which all the brazing alloy is liquid, liquidus. Brazing filler metal alloys. There are two magnesium filler metals in general use, BMG-1 and BMG-2A. Copper and copper-zinc filler metals are generally used on ferrous metals. Copper-phosphorus alloys are used to join copper and copper alloys. They are also used for silver, tungsten, and molybdenum. Brazing filler metal alloys. Silver-based filler metal alloys can be used to join ferrous or non-ferrous metals. Many alloys of silver have been developed. Silver brazing is often called silver soldering, but the correct term is silver brazing. Metals that form filler alloys with silver are copper, cadmium, and zinc. Silver alloys used for jewelry contain gold. Brazing filler metal alloys. Joints on most high-quality welding and cutting torches are silver brazed. Because of cost, silver alloys are most often used for brazing rather than braze welding. Brazing filler metal alloys. Cadmium and zinc are used as alloying metals in silver brazing because they have the ability to wet or flow and alloy with iron. Silver braze joints are very strong if properly made. Safety. There is a danger of producing harmful fumes if alloys containing zinc and cadmium are overheated and the metals vaporize. The work area should be well ventilated whenever zinc or cadmium is being heated. Brazing filler metal alloys. Gold filler metals are used in electronics and space technology applications. Nickel-based filler metals work well in cryogenic, very low temperature applications. Cobalt-based filler metals are used with cobalt alloys. Brazing filler metals can be applied by means of an applicator, generally pneumatic. Braze welding filler metals. There are 6 AWS classifications for copper or copper zinc based brazing and braze welding filler metals. Tin, iron, silicon, and manganese are added to some filler rods. A small electrical flow is created under certain conditions when dissimilar metals are in contact. This causes a type of corrosion called galvanic corrosion.